Alright, so for example 3 and 4 here, what I'm going to strongly encourage you guys to do is try it out yourselves. This is very close to what we did with permutations in the last lesson, so please give it a shot, or at least think about how you go about solving this one. But just like we did with permutations, what we're going to do is we're going to change these into factorials for both of these, and then we're going to simplify. Okay? So pause the video, give it a try, at least think about it, but once when you're ready, play the video and we'll go through the solutions. So example number 3 here says to express as factorials and then simplify. Here we have n choose 7, or n combination 7. Divide that by n minus 1 combination 5. So what we're going to do here is we're going to express each, the numerator and the denominator, as their own factorials, and then we will apply some rules to simplify. So starting off here, n choose 7, that can be written as n factorial over, that'll be n minus r, so the n minus 7 factorial, times that by r factorial, which is 7. And that's going to be divided by, we have n minus 1 combination 5, so that'll be n minus 1 factorial, divide that by, so that'll be n minus 1 minus r, which is 5, factorial, and then multiply that with 5 factorial, and then we can solve from here. Alright, so there's two different ways you guys can go about this. I'm open to either or. I'm just going to show you one solution. You guys can try another way. One way that you guys can solve this is simplify your numerator first and your denominator, and then evaluate that fraction. Or what we can do is we can use the rules about fractions dividing into fractions, where we flip our denominator and change the sign. And that's the one that I'm going to go with. If you guys want to use the other one, you guys are more than welcome to use that method. But I'm going to show the method for using our division rules. So with that, our first fraction, the numerator stays the same. So we have n factorial over n minus 7 factorial times 7 factorial. Then we're going to change the sign, so this is division. So we're going to change that to multiplication and flip our denominator fraction. So then our denominator for this fraction here will become the numerator. So we'll have n minus, and that's negative 1 minus 5, so it'd be negative 6 factorial times 5 factorial. I'll divide that by n minus 1 factorial. And then what we're going to do here is kind of going along the same lines of permutation. So remember how we rewrote n to be n minus 1 factorial? We're going to do that kind of the same way with each of these each of these factorials, and we're going to be able to cancel out some like terms. So for n factorial, we can notice that it looks like we can probably rewrite it so it looks something like n minus 1 factorial. So let's do that. So we have n times n minus 1 factorial. So remember, that's the exact same thing as n factorial. We just rewrote it to look a little bit different. That is divided by, and we have n minus 7 factorial. That one we can leave. So we'll have n minus 7 factorial. And what we can do is, with 7 factorial, we can rewrite this to look like 5 factorial. And I'm going to explain in just a second why we left n minus 7 factorial as it was. But for now, we'll just rewrite 7 factorial as 7 times 6 times 5 factorial. So we want to start canceling some like terms if we can by rewriting these factorials. Then we have n minus 6. This one I'm going to rewrite, and I want you guys to note, so when we go from n factorial, we subtract it by 1, so it'd be n times n minus 1 factorial. So with n minus 6, we want to make it 1 less. So it'd be n minus 6, and to make it 1 less, you subtract 1. So then that becomes n minus 7. So that's why we didn't rewrite 7. Normally you would think, well, we have to go down to n minus 6, but that's actually gaining. So remember, we're going to subtract, so we want to go from n minus 6 to n minus 7. So this one here we're going to rewrite as n minus 6 times 1 less, which is n minus 7 factorial. And we can leave 5 factorial as it is. As we can see from here, we can already cancel those like terms out. And, oops, sorry about that. And then we have n minus 1 factorial, which we'll leave as it is. So from here, we can start canceling out some like terms. So here we have n minus 1 and n minus 1. We have n minus 7 and n minus 7. Then we have 5 factorial and 5 factorial. So then what are we left with? Let's simplify. So we still have an n left. And this is, remember, this is all multiplication. So we have n minus 6. And that's it for our numerator. So now our denominator, we have 7 times 6 and nothing else. So from there we don't have to apply or distribute this n. We can leave that as it is, but I do want to simplify this denominator a little bit. So we can have n times n minus 6, divide that by 7 times 6 is 42. And so from there, we can't cancel out any more like terms, so we can leave that as it is. We're done. So now let's move on to number 4. So we're going to use the exact same process where we're going to, in order to solve this question, we're going to change this into factorials. It's a lot harder to see what the answer might be here, just looking at when we're given combinations. So when all else fails, always change it into factorials because it's so much easier to work with it then. Okay? So let's change here in each combination into factorials. So we have 3 times, we have n choose 3, so it'll be n factorial, divide that by n minus r, which is 3, factorial, times that by r factorial, and that is equal to n plus 1, choose 4, so it'll be n plus 1 factorial, divide that by, that'll be n plus 1, subtract r, factorial, and times that by r factorial. Then we can start, maybe we'll simplify this denominator first. So we'll have 3 times n factorial, divide that by n minus 3 factorial, 3 factorial is equal to n plus 1 factorial, divide that by, this is n plus 1 minus 4, so we can change this to n minus 3 factorial times 4 factorial. Now what we're going to do is we can actually rewrite this numerator, so we can go 3 times n factorial, and we can even rewrite 3 factorial so we can cancel something out. So what we can do is we'll have 3 n factorial, divide that by n minus 3 factorial, times that by 3 times 2 factorial. So remember, we can rewrite our 3 factorial. This really in itself, 3 factorial is just 3 times 2, because times that by 1 it'll just be the same thing, so we really could just go 3 times 2. And that is equal to n plus 1 factorial, divide that by n minus 3 factorial, times that by 4 factorial. Then we can cancel out our 3's here, and what we're left with is n factorial, divide that by n minus 3 factorial times 2. 2 factorial is just 2, and that is equal to n plus 1 factorial, divide that by n minus 3 factorial times 4 factorial. Now I'm doing this in a bunch of steps. If you guys can see this right away, that's absolutely fine. But what our next step is, if you guys notice, we have n minus 3 factorial on both sides in the denominator. And we can do this because there's an equal sign. So what we're going to do is we're going to multiply both sides by n minus 3 factorial. So multiply n minus 3 factorial on both sides. Then those will cancel out. So it actually worked out very nice. So what we're left with there is n factorial, divide that by 2, is equal to n plus 1 factorial, divide that by 4 factorial. From there, what we can do is, and there's a bunch of different options we can do with this. We can get rid of our denominators. Since we have two fractions, we can do a cross multiply and divide. Either way, you'll get the exact same answer as long as you do those steps right. So what I'm going to do is I'm going to cross multiply and divide, or sorry, just cross multiply. Yikes. Okay, so cross multiply. So we have 4 factorial times n factorial, which is equal to 2 times n plus 1 factorial. I'm going to simplify 4 factorial here. So we have 4 times 3 times 2 times n factorial is equal to 2 times n plus 1 factorial. Then from here we can divide each side by 2. That'll cancel out those 2's there. And so what we have left is 12 n factorial is equal to n plus 1 factorial. Now if you guys can guess, I'm going to rewrite one of these factorials to look like the other so we can cancel out some like terms. And I'm going to rewrite n plus 1, because remember when we change this into factorials and we're going to rewrite this, it becomes 1 less. So if we subtract 1, it'll just become n. So we have 12 times n factorial is equal to n plus 1 times it by n factorial. Then we can divide each side by n factorial. That'll cancel out your n factorials. I'm just going to scroll on down here. And what we're left with there is 12 is equal to n plus 1. Then you can move this 1 to the other side, so we'll subtract each side by 1. So that means that n is equal to 11. Alright? And then if you want to, you guys can go back, plug in those values, you guys can check it to make sure it actually works, so verify it. With that, our question is done. We solved for n. So you guys can go ahead and get started on your homework.